In this video, we are going to discuss class 11th Mathematics Chapter 1 Sets. Introduction to Exercise 1.2. We will discuss the concepts and the formula required to solve the problems given in Exercise 1.2. See the link below for the video on Introduction to Sets and Solutions to Exercise 1.1. The first concept is empty sets. See the definitions. A set which does not contain any element is called the empty set, or null set, or void set. The empty set is denoted by symbol phi, or this empty curly brackets, no element is mentioned in that. Phi is pronounced as phi, phi, and written like a circle and an oblique. The examples of empty sets. Let us see. Set of rectangles with 3 sides. This rectangle you have 4 sides, so there is no rectangle with 3 sides. This is an empty set. Let A is equal to x such that 1 is less than x is less than 2. X is a natural number. 1 natural numbers are 1, 2, 3. It goes on like that, and there is no number in between 1 and 2. So A is an empty set. Next one. Set B is x is such that x square minus 2 equals to 0, and x is a rational number. What is x square minus 2 solution is x plus or minus 2, and x is equal to x equals to plus or minus 2. But you clearly know square root of 2 is a irrational number. This is irrational number. So this set is an empty set. Next one. C is x is an even prime number and greater than 2. C is an empty set because the only even prime number is 2. The condition given is even prime number greater than 2. So this is an empty set. Next, D is x such that x square is equal to 4 and x is odd. X equals to plus 2 or minus 2. Then D is an empty set because none of them are odd. X square is equal to 4 is not satisfied by any odd value of x. We will move to the next slide. Next concept is finite and infinite sets. What are finite sets? A set which is an empty or consists of a definite number of elements is called finite set. An empty set means it is having 0 number of elements. That means no element. So 0 is a finite number. Next, infinite set. A set which consists an uncountable number of elements is infinite set. Which are not finite sets are infinite sets. That means which are having uncountable number of elements is called infinite set. This is having a definite number of elements, and infinite sets is uncountable number of elements. We'll see an example. Let A is equal to 1, 2, 3, 4, 5. B is A, B, C, D, E, F, and C is men living presently in different parts of the world. We observe that A contains 5 elements and B contains 6 elements. How many elements does C contain? Definitely it is some natural number and maybe quite big but is countable. Right? We'll give a notation how to write number of elements. Number of distinct elements of the set can be denoted by ns. Number of elements, name of the set. S is the name of the set. N is the number of elements. If ns is a natural number, then S is a non-empty finite set. That's the definition you can take. The sets A, B, C are Na is 5, Nb is 6, Nc is some finite number. So, in denoting with ns, you got an idea that these sets are finite sets. We'll see the examples of infinite sets. Let A be the set of prime numbers. What are all the prime numbers? 2, 3, 5, 7. It goes on like that. It is not definitely countable number. So it is a infinite set of numbers. Second one is let B be 2, 4, 6, 8. and it goes on like that. Is a set of all even numbers. So they are also not countable. So this is infinite set. Now we'll consider some sets given below. State which of the following sets are finite or infinite. See, first one is x is such that x belongs to n natural number and x square is equal to 4. X square is equal to 4 means what? X is equal to plus or minus 2. So x should be, it's a natural number. So it should be 2. This is the set. The set is 2. So this is a finite set. Next one, 4, 8, 12, 96. This is a multiple of 4. That means x such that x belongs to natural number and x equals to 4n. So, but less than 90 up to 96. So this is a definitely a countable number. It is finite. X is a point on a line. Point doesn't have a dimension. Length, breadth, height. No dimension is there. One straight line is made of an infinite number of points. So this is a infinite set. Set of days in a week. This is definitely a finite set. 7 days in a week. So finite set. X belongs, next one is x is such that x belongs to n and x is odd. These are 1, 3, 5, 7 and it goes on like this. This is also not countable. It goes to infinity. This is infinite set. Set of integers less than 100. Guess what? Finite or infinite set? Yes, it is a infinite set because it starts from minus infinity, minus 3, minus 2, minus 1, 0, 1, 2, up to 100. So definitely this is not countable. This is infinite set. Last one, set of natural numbers less than 100. This is less than 100. One, the natural number starts from 1, 2, 3, up to 100. This is definitely countable. So this is a finite set. We'll move to the next slide with a new concept. Equal sets. Two sets are A and B are said to be equal if they have exactly the same elements. That means if you have got same elements, those sets are to be said to be equal. We write A equals to B. Otherwise, they said they are not equal, then A is not equal to B. See, A equals to 3, 2, 1 and B equals to 1, 2, 3. These two are equal sets. Okay, that's it. Now empty sets are equal to each other. Empty sets means this, no element is there. So other empty set is this. Is it different from this? No. Both are equal, same. 5, so 5 is equal to 5 or null set, equals to null set. We consider the following examples. See, let A is equal to 1, 2, 3, 4, B is equal to 3, 1, 4, 2. So 1, 2, 3, 4 elements are all present in B. So A is equals to B. Let A be the set of prime numbers less than 6 and P the set of prime factors of 30. Prime numbers less than 6 are what? 2, 3, 5. This is A. What are the prime factors of 30? Prime factors. The factors are 1, 2 is there, 3 is there, 5 is there, 6 also factor but not a prime factor. Similarly, other factors are not prime factors, but 2, 3, 5 are only prime factors. So both elements are same. You can see A equals to T. Now X is a positive integer. X is a positive integer. That means what? It starts from 0, 1, 2, 3, like that. Remember, 0 is a positive integer. 0 is a positive number, positive integer. Very important to note that 0 is a positive integer. So D is what? Now C is 0, 1, 2, 3, so on, and D is natural number. X is such that 1, 2, 3, it goes on like that. Obviously, C is not equal to D. Remember, in this such type of questions are tricky. You have to be careful. The C is not equal to D. We will move to the next slide with a new concept. Next one is singleton set. Singleton set means which has only one element, exactly one element. See, you can give an example, set of even prime numbers. What are the even prime numbers? This is the only even prime number. Rest of all are the prime numbers. Month that have 28 days in a non-leap year. This is February. This is the only month which is having 28 days in non-leap year. X is neither prime nor composite. What is that number? Which is neither prime nor composite. 1 is neither prime, it's not a prime number, not a composite number. So these are the examples of singleton set. First we learned about the empty sets, that means empty sets which doesn't have any element, which is denoted by 5. And finite and infinite sets. Finite means a countable number of sets, and infinite means it has got uncountable number of elements. Equal sets. This means both, if two sets are having exactly the same number of elements, it is equal sets. Singleton sets, which having exactly only one element, is singleton sets. So that concludes the video. We'll meet you in the next video with the solutions to exercise 1.2. See you then.